Okay, I think we can start. It's 4 p.m. now. So, I think everyone can see my screen. So, good afternoon, everyone. Our topic is about nets, as you may already know by the title. First, let me just introduce myself a little bit. My name is Thais. About my education, I have a bachelor degree in mechanical engineering. I also studied management information technology, and right now I'm studying system analysis and I'm doing an internship in RDI. So here is our agenda. We're gonna talk about distributed systems, pub-sub pattern, nets, how to run a net server, net CLI, and we're gonna show the nets functionalities using C#. So, what is nets? Nets is a simple cloud-native messaging system for building cloud-native distributed system. Distributed system, I think, is very important just to give a short presentation about this topic in order to understand why Nets empowers distributed systems so much. I've already prepared a short presentation. Let's see it in the next slide. I'll start with one example. Let's suppose I want to store data in a database. What I would do traditionally is store this database I created in one single machine. So I'll have a database software in a computer and that's it. That's enough. A database in a file system. Now let's suppose the data traffic keeps growing and growing and growing. One solution I could have for this problem is scale vertically. What does it mean? Well, it means that I can upgrade my hardware. So instead of the old computer that you see here, I can replace it with a new one, smarter computer. If my traffic keeps growing, no problem. I can replace the other one with a super new one computer, right? Not exactly. Look, there's nothing wrong with vertical scalability. But at certain point, the costs are so high that I can't do this anymore. So sometimes, in some cases, it isn't the best solution. How can I have a better approach for this kind of situation? Well, we can scale horizontally. We can change the way we deal with the situation. Let's talk about distributed systems. Just to keep it simple, I'll repeat the same situation. Just remembering, I want to store data in a database. The initial idea is pretty much the same. When the traffic is not so high, I can have just one single machine and a database software and the problem is solved. But we realize the distributed system approach changed a little bit once the traffic keeps growing. When the database traffic is high, instead of replacing this good computer that I already have here, I can just add one more. And the two computers have a communication with each other. That's the idea. If my traffic keeps growing, no problem. I can add one more and one more and one more. So the advantage of this system, we have a lot of benefits. One of them is very important because it saves money. Horizontal scalability becomes much more efficient after a certain point. We also have a better administration compared with the previous example, because if the traffic keeps growing, I can just add one more computer. And it fails independently without affecting the whole system. It means that if one computer fails, it won't affect the others as it did before in the previous example that we had just one computer. So distributed systems are really good. We have a lot of advantages, but they are recognized as a complex topic. So why is it so complex? Distributed systems is actually not so easy to implement and maintain. We need software specifically designed for this kind of systems in order to connect all these components that you see here. And one of them is distributed message brokers. Distributed message provides a essential place for storage and propagations of messages inside the systems. And we have a lot of different message brokers. One of them is Nets, our Hangouts topic. So why Nets is especially designed for distributed systems? Let's talk about it. I'll try to explain why Nets is so special with one problem that I got here. Let's suppose I want to establish communication between services A, B, C, and D. The traditional way is to use the HTTP protocol. In order to connect all of them, I have to know what machine, what port, what path each one is located. Okay, now I have a beautiful connection here. But let's suppose service B changed its address from example.com to serviceb.com. What happened? Everything is broken now. While I don't update, while I don't inform the new address of source B manually in each one of the sources, services A, C, and D, everything here will remain in this broken state. So I'll have to update this new address of source B in each one of the sources. If I had 100 services, I'd have to do it for each one manually. So that's a big problem, a big deal we got here. Now let's see the same scenario with nets. Nets roots is based on subjects, not by IP port. So location doesn't matter for nets. In this example here, service A wants to publish something in the test subject, so let's call it publisher. Who wants to publish something for services B and C. With nets, we have this architecture. All the services are connected to nets. They don't have a connection with each other. And as I said, it's based on subject. So the publisher publishes something in the test subject, and any services which is interested in the subject needs to subscribe to this specific topic. And now we have all services communicating with each other, which is what we were looking for when we talk about distributed systems. So just to summarize, nets can be thought as a mailbox between publisher applications and subscriber applications. And nets is really good because it is simple, it's lightweight, and about the communication, it can adopt a lot of different formats. So let's see it. It can be many-to-many. It means that we have a lot of publisher applications and a lot of subscriber applications. It can be one-to-many or fan out. It means that we have just one publisher and a lot of subscribers. Or it can be many-to-one or fan in. It means that we have a lot of publishers and just one subscriber. Next, what I want to do is just to present a quick demo. But before it, I just want to show the most part of the command stack that Net supports here in this table. So let's see in practice how to run a Net server. Let's go to the demo. I want to show you how I can run a Net server, a standalone Net server, and with Docker. First, let's see the standalone version. So I'll stop the presentation here. And the standalone version, we have this beautiful page here of GitHub. I'm gonna leave the link of this page in the comment section or in the description. You have to choose the Net server zip based on your operating system. For example, here I'm using the Windows 10 64-bit operating system. So if I had to choose one, I would choose this one here. If that's your case, you can choose this one. And you have to extract all the content in any folder. I already did it. I can show the content that we have in this folder. It's right here. Let me just find it. Okay, it's right here. So here we have the license, the Net server, and the README. So if I click here in the Net server and press enter, we can see the server is ready. Pretty fast. Okay, that's one way. I can show you another way, which is via Docker. The only prerequisite is you already have Docker in your machine. That's my case. I have the Docker desktop pro Windows here. So I'll just open the Docker here, and I'll open the command prompt as well. So here in the command prompt, I'm gonna type Docker commands nuts server. To be able to see all the commands, I'm gonna press enter. So I want to pull an image. I'm gonna type Docker pull nuts latest. I'm gonna press enter. And with this command, you don't need to define and configure the image on your own. Now to run, we type Docker run p 4222, which is the standard port of NATS. 4222 again. TI NATS latest. I'm gonna press enter. And now the NAT server is running. If I open the Docker here, we can see it's all green here, so it's already running. Perfect, pretty fast. Okay, next what I want to show you is how NetCLI works. But first, you're gonna need to download the NetCLI. So again, we have this beautiful page here of GitHub. I'm gonna leave the link of this page in the comment section or in the description. You have to choose the NetCLI zip based on your operating system. For example, here I'm using the Windows 10 64-bit operating system. So if I have to choose one, I would choose this one here. If that's your case, you can choose this one. And we have to extract all the content in any folder. I already did it. I can show the content that we have in this folder. Let me just look for it here. I think it's right here, the NetCLI. Okay. I have a lot of content here. We have the license, the NetCLI, and the README. So in the terminal that you're gonna use, in order to execute the commands, you have to copy this path that you have the NetCLI and paste it in the terminal that you're gonna use. For example, here I'm using the hyper. So just paste into the terminal that you're gonna use. Once you did this, you can type commands. So the first thing I want to show you is the one-to-many or fan-out model in the pub-sub pattern. So in my case, I'll have one publisher and 3 subscribers. This first terminal here is gonna be my publisher, and the rest is gonna be my subscribers. The first thing to do is to subscribe in one subject. I can give it any name. In this case, I'll call it test. So I'm gonna type nats sub test. Sub means subscribe, so I want to subscribe in the test subject. And here I'm gonna do the same, that's sub test. And that's sub test. Okay, perfect. Next thing is publish something in the test subject. So I'll go here in the first terminal, which is my publisher terminal, and I'll type nets pub, which means publish. I want to publish something in the test subject. And the count means the number of messages that I want to publish. In my case, I want to publish 1,000 messages. That's a lot of messages. I want to publish 1,000 messages. And the message is gonna be message. Message. It will count. And it will show the time as well. Okay, let me just check if everything's correct. Net pub task count is equals 1,000. Okay, it seems that everything's correct. So when I press enter here, it has to appear the same content in this first terminal, in the second terminal, and in the third terminal. So I'm just gonna press enter. And we can see the 3 terminals receive the same message. If I check the content of this first terminal, we can see is the same of this second terminal and the third terminal. Okay, we can see by the output it's working as expected. Then there's another thing, which is load balancing. Because what net support is queue groups. We can't implement the competing consumer pattern, so the net server will automatically divide the methods over the terminals. So in order to execute this, I'm gonna type nets sub demo.1, which is the subject, and queue demo, which is the group that I want to join. I'm gonna press enter, and here I'm gonna do the same, nets sub demo.1, which is the subject, and queue demo, which is the group that I want to join. I'm gonna press enter. And I'll go here in the first terminal, which is my publisher terminal, and I'll type nets pub. I want to publish something in the demo.1 subject. And the count is gonna be 10 this time. I want to publish only 10 methods, not 1000 methods. And the message is gonna be message. It will count. And it will show the time as well. Okay, let me just check if everything's correct. Let's pub demo.1, count equals 10, message count. Okay, it seems that everything's correct. So when I press enter here, it has to appear part of the message in this first terminal and part of the message in the second terminal. So I'm just gonna press enter, and we can see the message 1, 2, 3, 4, 5, 6, and 8 is in this first terminal, and the message 7 and 9 is in the second terminal. Okay, we can see it's randomly divided between the two terminals, and it's all server side. Load balancing by the net server, which is pretty useful and is completely random. It's not 50-50. Okay, that's all of my presentation. Next, we're gonna see the Nets functionalities using C#. My friend Thiago is gonna start this presentation. Thank you very much for your attention, and Thiago, you can start. Maybe you're gonna have some delay here in this video on YouTube. If that happens, please just wait a little bit.
Someone in the chat, please. Can you tell me if you're hearing me? Oh, okay. Thank you, Brazão. Thank you so much. Okay, hello everybody. My name is Thiago. I've been a developer for over 10 years now. Oh, that's too much people answering me. Okay. Uh, I would like to show you a few things with Nets and C Sharp using .NET Core. This is not a tutorial for any sort of programming, so I will assume that you guys are familiar with Visual Studio 2019 and programming with C Sharp. The first thing I would like to show you guys is I will run a local net server, just like my friend Thais showed you before. I will be using Docker. I'll map the default port, and I'll use the net's latest image, and I also want to pass in a -v argument, which will enable logging in our server. This is pretty handy when you're still building your applications. As you can see, the container started. We already have some logs here, so we can jump into the code. I will apologize though for something. My camera is on this side and my screen is on the other side, so I will apologize for not looking straight to the camera all the time. Okay. Moving on. I want to create a console application. I will just name it Nets Client 1. Next, I will be working with .NET Core 3.1. Let's wait for the Visual Studio to create the project. And here we go. Okay. So the first thing to use with your nets is to right click on the project and go to manage NuGet packages. You can use the NuGet package console for this. I just rather do it this way. I think it's easier. I'll just select the browse tab, and here we'll type nets.client, and we will install this one today. It's August 4th. This is the latest version 0.12.0. Just click install in your project. It'll prompt you for, I think, for a license. Yeah, hit accept, and we are good to go. So in here we can already type in using nets.client, and like my friend Thais showed you before, the first thing I want to do is publish a message to our server. So in order to do that, I will declare a variable called URL, which will take our net server address. Nets uses its own protocol, so it starts with nets 2.//. So it's, since it's in my Docker, I will use my Docker gateway, and now we can create a connection to the net server by creating a new connection factory and calling the method create connection, passing our URL as parameter. So this will give us a connection to our net server. So to publish a message, it's easy as typing connection dot publish. So we can specify a subject, let's say test, and our message, it takes a byte array of data. So byte array of data is a little tricky, but it's pretty simple. We can just declare a new variable and use the system text encoding to parse this from a string. Let's say hello world. We pass in the message. Let's just type in a log, and I want the program to wait for an input before closing. So if I run this, okay, so if we check our logs on our net server, we can see the message was published here. So to publish a message is really straightforward, few lines of code, very easy to do. So the next thing I want to do is to subscribe to a subject, so we can start listening to different messages. So I will add another project to our solution. It will be another console application. Let's call it Nets Client 2 because I lack imagination. And we'll be using the .NET Core 3.1 version. So the first thing is to add the Nets Client package. I can edit our first project and grab this XML node here and just paste it on our second project. And here we can start with using Nets client. Uh, the first things is remain the same. So declare a variable with your net server address, create a connection, passing in that variable, and we are good to go. But instead of calling a publish method, we'll be calling a subscribe async method. So this method will take a subject to subscribe to, and we will take, oh, another option is to add a queue, but we won't talk about this now. We will just pass in a event handler. So here I can just use a lambda function, a delegate. We can pass in a object sender, and here we can grab our message, which will be in this msg.message.data. This is our array of bytes, but we would like to convert this into a string. So let's create a variable called decoded message and use the syntax encoding to get ourselves a string. So in here we can type in console write line message received console write line decoded message. In here I would like to make the program wait before finishes execution. Another thing I would like to add is I'll just add a small delay here. Let's create using the threading task delay about 2 seconds. I think is more than enough. So when I run this, oh, sorry, forgot to do something, which is we're going to right click our solution and set startup projects and select multiple startup projects. Right click here, select start. This way we'll start both of the applications at the same time. Now we can run it. So here's my Nets client 2 and our Nets client 1. Publish the message and the client 2 got the message. If you check the net server, we can see that it published the same message again. It's all good. Everything is working fine. Okay. So now we already know how to publish a message using C#, how to subscribe to a subject, and you guys can see it's too small. Maybe like this. Can anyone see like this? Hopefully. Oh yeah. Hopefully you can see now. So where was I? I was trying to, okay, publish subject and subscribe, and now I would like to, I'd like to talk to you about a cool feature Nets has, which is request response. Uh, so let's imagine I want client 1 to send a message to client 2, but then I would like to answer that message. So I could simply come here and say connection dot publish to a certain subject and send a response and so on. But here I will have to create a subscription to that same topic, same subject. All right. Nets has this built in already. So instead of sending publish, we can use connection request and passing a message or our subject and array of bytes. But this method will return to us a response. And here, instead of subscribing instead of publishing a message, we can use the msg.message.respond and send back an array of data. So let's create a var response, which will be encoding UTF-8 get bytes hello back. And here, instead of a message publish, we need to grab a decoded message, a decoded response, which will again use the encoding UTF-8 get string response dot data. So instead of this, we'll log something like client 2 responded and the response. If we run again, the Nets client 1 sends the message hello world to the client 2, and the client 2 is able to respond to that message. That's pretty sweet, because behind the scenes, what really happens is exactly the same thing that I told you guys before, which is publishing a message to a subject. When you use this method, we will create a temporary subject in order for the clients to respond. So they use the same publishing message mechanism in order to solve this request response issue. Okay, next thing I would like to tell you guys about is synchronous messaging. Here I used subscribe async, which is asynchronous, which means this will not block the execution of the code. So if I remove this line, for example, the program will execute, will not wait for any sort of inputs, it will automatically close, because the asynchronous method does not block your thread. But we have another way of doing this, which is with subscribe sync method. This time we will not pass in a delegate, but we will have to get the subscription for this, and now we can get next message. and this message is the same message that Nets give us, so we need to decode again. Get string message data. And now we can write message received and not decoded message, decoded message. We have to change these two because it's not awaiting for a response anymore, so we can change this to publish. And just change this to message published. Let's run this. So we get the same result as before, but this time this method, which subscribe sync, this method is synchronous. So when you invoke the next message method, this will block your thread. So it is something that you might take into consideration. Okay, one of the parameters that you can pass in is a timeout in, I'm not sure if in milliseconds. So maybe you will need that message. You wait for that message just for a window in time, and that's it. Another cool thing that we can do with this is we can create a loop. So our client 2 will answer only 10 messages. But you can also do it with the asynchronous version. You can use the subscribe async. Let's use an empty message just to, I want to show you guys something else. Oh, this is not a empty message. This has to be a delegate. So object message this, which this will give us a subscription object. There is already subscription. Okay, let's comment this code real quick. And this subscription has a method called auto unsubscribe, which will do basically the same thing as this. You can pass in a number of messages that will handle, and then will automatically unsubscribe your client from that server. I think this is another pretty cool thing that Nats did. And let's see what else I want to show you guys. There is so much about Nats that I like that I had to tone it down a little bit. Okay, next thing I want to show you guys is not the will be sending complex objects. So our publisher will be this client 1, but instead of sending a simple string, I want to send, let's say, a model class. I don't know, maybe we can call it a custom model user defined class. If that's not explicit enough for you, I'm sorry. Let's give it a few properties just to show you guys how easy it is. ID and name, that should be enough. So instead of sending a hello world string, I would like to send a custom model user defined. ID will be 1, name will be me. So from my experience, the easiest way to do this is just by serializing your model into a JSON string. And to do that, instead of using the encoding namespace, we will be using Newton Soft. You can also use the namespace built in from on the .NET Core. I'm just not more used to the Newton Soft. Maybe I'm old, I don't know. Just type in JSON convert.serialize objects. You pass in your model, and now this is a string which can decode to an array of bytes. I think this is the easiest way to send in a complex object. There are very other ways to do that, but I think this is the easiest one. So the other thing we want to do is how we can receive this message. So we know that we will receive a byte array, which can which we can decode to a string, but we also know that this is a JSON string. So we can use this UTF-8 get string msg dot message dot data, and now we can use the same namespace from Newton Soft. Instead of serializing, we will deserialize our objects, but we need to pass in a model to deserialize too. So let's copy this model and set it here. Now we can pass in our string to deserialize, and there you go. Here we can just type in console right line message received. Let's write some properties like ID. Let's just put this in a string interpolation, and our name. So if we run this, we successfully managed to send a complex object over nets. So there is other ways of accomplishing the same thing, but while my time using nets, I think this is the easiest way of sending complex data. Okay, some other stuff I would like to talk about, which is wildcards on subjects. Oh, this is awesome. So, as you guys know, we can create a very different number of subjects, but something that Nats does is it supports alphanumeric characters and some special characters, let's call it, which is the dot, the asterisk, and the greater than sign. I will explain them right now. So when you use the dot, for nets, it creates some sort of hierarchy in the subject. So in here, instead of subscribing just to the test, I'll have to subscribe to test.1. Let's create another subscription to the test.2, subscription 2. And now here we can, let's copy these, just there is some time between the messages. Let's publish another message to the second topic. But if I publish to another topic, to another subject, like dot 3, that one won't be received because the client 2 is not subscribed to that subject. So let's see this. Okay, so like I said, the first client did publish these 3 messages. If you go to the nets logs, we can see here uh, pub test.1, pub test.2, pub test.3. But our second client could only receive the test.1 and test.2 because those are the subjects that it was subscribed to. So we can do, instead of creating any number of different subscription, we can use wildcards like asterisk, for example. So if you rerun the same thing, now it gets the 3 messages. So this will match any sort of subject after the test dot. But if we publish a message to, let's say, test.1 dot another, oh, not caps lock, not uppercase, another test, this one won't be received by this client. Just 2 messages, you see, because this wildcard will match only the next level in this hierarchy. In order to match any level after this, we have to use the greater than sign. I think this is a very interesting feature because, like I said, you can create some sort of hierarchy using the subjects. So let's say you have applications distributed across your country, so you can, or even around the globe, you could publish messages like country.state.city. Anything else, district. And with this and the wildcards that are allowed in the subscriptions, you can create very complex ways of dealing with these messages. Okay, I think this is most of the things that I would like to show you guys using C# code. I would still want to talk about just a little some other stuff that I think it might be useful for you, which is event handlers. So in the connection, not in the connection, but in order to get some event handlers related to your connection, you need to get the default options. So let's create a variable called options, and this is a static method, get default options from the connection factory. And here we can see some event handlers like async error event handler. So when your connection has a error, it will throw an event here, so you can create your own delegate and deal with custom errors. Not custom errors, but custom error handling. Another thing that might be useful is on connection closed and the disconnected event handler. I think those three are the most common ones. There are a few others, I think, but I will leave you guys to dig in. But this is pretty straightforward. Just get the options from the connection factory and create your delegates here. Other thing that I like to show you guys is some of these objects do implement the iDisposable interface. So the connection, for example, is one of them. So it might be useful for you to type in some usings before to dispose these objects when you see fit. Another one is the subscription. I think it also implements the iDisposable. Yeah. So this way, the framework will handle the disposing of the objects for you. Of course, just be careful if you are creating a connection and you're hoping that connection is alive throughout the execution of your program, don't use it, of course. But if you're not, it may be something that you fire and forget, some messages that you don't need to wait for some sort of response, just dispatch it. This is a pretty easy way you can dispose the connection. Another thing I would like to tell you guys about is how to connect to a Nets cluster. It's pretty simple. You just have to, instead of passing a single URL, you will have to get the options, and in the options we have a field for servers, which is a array of strings. So in here you're passing different, all the addresses from the servers that are part of your Nets cluster. For example, instead of sending the URL here, just passing the options and you're good to go. It's easy as that. Nets also supports a lot of different forms of authentication and security. So if you're planning on using these on the web, maybe as a cloud services, you might need to consider taking a look at those authentication and security options. I won't dive in too deep here because we have a limited time, but be sure that Nets does have security options. I think one of the last things I want to talk about is Nets streaming. So Nets has additional capabilities which are not enabled by default. You have to pass in a command line variable argument. Sorry, argument. I believe it is minus JS for Jetstream, I think. But what it does, it enables additional features for Nets, like a at least once delivery policy. So if you send a message like in this configuration that I showed you guys, if Nets client 1 sends a message and Nets client 2 is not yet subscribed, it will lose that message. So with Jetstream, you can specify a policy so every message gets delivered at least once to each subscribed client. We also have durable subscriptions, which is another pretty cool feature if in terms of resilience. Let's say if client 2 for some reason it stops working, stops running. So when it gets back up, it will automatically resume the activities from nets from the moment it went down. So any message that it might have missed will be replayed to this client. And the net server will have the ability to store and replay messages by time or sequence. So I think those features are really great in terms of resilience, and it all it is all enabled by a simple command line argument. Unfortunately, though, our Nets client for .NET specifically does not have those functionalities yet implemented. I think they have plans to implement by the end of this year, I hope. But as far as I know, they are not. So I think the solution might be either use another language as a client, or you can use another Nets client, which there are another ones, but they are not the official, like they don't have the support of the Nets team. So use it at your own risk. Okay. What else I would like to say? Yeah, Nets has clients written in so many different languages, I cannot name them all. I'll just say Java, JavaScript, Python, Go, Scala. There's a whole list of different clients that already implemented. And I guess that's it. I think it's if I start talking more about nets, I'll be dwelling into more advanced uses. So I'll keep this as it is. I would like to tell you guys what you guys think about nets, and if you have any questions. I will just post here. Let your guy let this. This is the official repository for the Nets clients. So if you guys want to check it out, just go there and dive into the documentation. So I'm not sure how much longer I'm supposed to wait. So I guess we can wrap it up. And if you guys have any question, feel free to comment in the YouTube. We'll do our best to answer every question. Okay? So thank you all for your time. I really appreciate it. It was really fun. I hope you guys have enjoyed as much as I did. And we'll see you guys next time.